So this is lecture 8, and it's about the Coriolis force and Ekman layer. The Coriolis force is an additional force that comes into play in rotating fluids, in fluids that are placed in a rotating frame of reference, like the oceans on Earth, or if you put a bowl with water onto a turn. Right? So this is what this lecture is about. It's about the finite difference formulation of, which is another little hurdle, as you will see. And we talk about Ekman layer then. Okay, so the starting point is you just only look at the Coriolis force, no other forces, only horizontal currents, and you can formulate the Coriolis force like shown here with these. Okay, so there's a parameter in there, this omega. Okay, and you can see that there's a 2 there, and there's the v in the u equation and the u in the v. So if you study this a little bit, there's a number of things that you learn. First, and the most important thing is that the Coriolis force operates perpendicular to the direction of the flow. And this is shown here on the left hand. Depends on the sense of rotation. So on Earth, for example, in the northern hemisphere, the Coriolis force operates to the right, and in the southern hemisphere to the left with respect to the flow. So what is this omega here? The omega is actually the frequency. It's 2 pi over the time span of one rotation. If you have a turntable and you measure the time it takes for one rotation, the omega is just 2 pi over the period. Okay? So let's have a look at it. And these are the equations. You actually can exactly solve this equation. First thing I want to do is I want to show you the analytical solution.